So once we recognize we have an embedded function, we need to recognize which function is the outside function and which function is the inside function. Okay, so my outside function, my f as a function of u, is going to be the cube root function. Okay, and then my inside function, which I'll call u, my u function is going to be the cos 2x function. So as I differentiate this then, as I find my derivative, dy by dx, I'm just going to write that as dy by dx. Okay, I want to multiply the dy by du times du by dx, and then that will give me my overall rate. So my dy by du is going to be differentiating the cube root function, so I'm going to end up with 1/3 to the power negative 2/3. Okay, and that inside function is the cos function, cosine of 2x. So I've differentiated the outside function with respect to the inside function and not changing the inside function, and then multiply that by the derivative of that inside function, and I have to multiply by 2, but we can also think of that 2 as actually an innermost function. Okay, so we know that we're going to have times 2 here. So, but now, and we did that with a horizontal compression, but we can actually now apply, instead of thinking of this horizontal compression, we can actually apply the chain rule here, because I can actually do this. Okay, so I'm going to call this my v function, cosine of v, and then the v function is just the innermost 2x function. Okay, so this is going to be 2x. I can just say that there's actually 3 layers to this. So I can say my outside function is in red, differentiated. My inside function has been differentiated, okay, in green. And then I can differentiate my next inside, which is 2x, which is just the derivative of that is times 2. Now, this times 2 showed up earlier, but we just said it's because of horizontal compression. But really now it's much easier to deal with this extra times 2, not as a horizontal compression, but just as a chain rule. And we can think of it as an inner function with slope of 2, so we multiply that slope of 2 at the end. So that is a much easier way to now think of that horizontal compression. In fact, from now on we're going to maybe describe this with chain rule instead of horizontal compression. So just cleaning this up, I get negative 2 sine of 2x over 3, and this is a cube root of cosine squared 2x, and there it is. There's my final derivative. For this question here, we want to know where this function has horizontal tangents. Not exactly sure what this looks like, but it's probably some sort of exponential function. So we need to differentiate this to see if we have horizontal tangents anywhere. Okay, so f prime of x, we're going to differentiate the outside, so everything stays the same when we differentiate the outside. But then we need to recognize that there is a squared function inside the e to the x function. So when we differentiate the squared function, we get 2 power 1. Okay, I'm just going to leave that power 1 out. So there is my derivative. I had to recognize that there is an inside function, so I have to apply the chain rule. So there's my derivative. And then if I want to know where this function has horizontal tangent lines, I'm going to find where this derivative is equal to 0. So I know that's 2x plus 3 e to the x plus 3 squared. Okay, well, I know that this part has no solution. Okay, and I know that then the only solutions must come from this factor. So at x equals negative 3, we have a horizontal tangent line. And when x equals negative 3, y is equal to, and it looks like y is equal to 1 when I plug it in.